All right, so next I'm going to explain how we can use really large data files in PyMINEr. So we're going to use the same file just for expediency. So it's the same example file, same genes of interest, same everything. So just to make sure none of the results from the previous run interfere, we'll clean up the directory. We'll start from scratch. So here, if we list the things in the data file, now we're back to just airway merged.txt. So included in the PyMINEr distribution is a script called tab2h5py. So if we print out the help, basically I would not suggest using the sparse argument because everything runs a lot slower, unless your data set is absurdly large. But even for data sets of hundreds of thousands of cells, the final file size without making it sparse is still not arduously large. It's about 20 gigs or so, something in that neighborhood, and things run up to 10 times faster when it's without using the sparse argument. So in this case, we'll go ahead and use the im file is just airway merge.txt, and there it goes. It's making the HDF5 file now. And if we look at what's now in the directory, is airway merge.hdf5 and two other files called ID list and column IDs. So to use these, we'll do first we'll go into the trash and see if we can find the genes of interest file that I did not mean to delete. Genes of interest. All right. Let's restore that. Then we'll look back over here. Genes of interest. Just double check everything looks good. So, of course, the first column here is the gene ID in the same exact format that it appears in your data set. And then if you want to give it a nickname or an alias, you have that in the second column. But you don't have to have a second column at all. All right, so now the genes of interest is back there. Now we'll look at it again, and it's there. All right, so the call will be PyMINEr.py. In file is airway merge.hdf5 this time, and so that PyMINEr knows that it's an HDF5 file, we have to tell it HDF5. And then the ID list we have to feed in as ID list.txt. And then columns is column IDs. And then again, species was mouse. Spelled that right. And then what else? We have the genes of interest. And essentially, if you want to do it interactively within Python, like we did before, it's essentially the exact same arguments that you see here, except HDF5 equals true instead of just saying HDF5. And that's about it. And again, we'll also feed in AP clust so that the results come out consistent with the last run. And there it goes, off and away. And we should get the same results as we did the last time. Now, this will be more useful when you have files that have more than hundreds of cells. At that point, it's not going to go much slower or quicker if you do an HDF5 file conversion, but at some point you want to stop having to hold all of your cells in the memory, and HDF5 is really the only way to do that. And for those of you that are familiar enough with the HDF5 file format or want to learn a little bit about it, it's essentially just the PyMINEr accessible form of an HDF5 file is very simple. It's just it's only got one object in it. It's the HDF5 container, and there's only one object in it, like I said, and that's called infile, infile. And that's basically just the matrix representation of all of your data, and there's nothing else in there. You can add whatever you want to it, but as long as you make an HDF5 file that has the term infile as a keyword, then and it's a dense matrix. I guess it doesn't have to be a dense matrix, but it runs a lot quicker if it is. Then yeah, you should be able to run just fine, as long as you also feed in the arguments ID list, which has all of your row IDs. So these are going to be the genes, and then your column IDs. So those are all the genes, of course, and then your column IDs are all of the cell labels that you have. This one actually requires a header, and yeah, that's about it. And I'll check back in at the end of this run to show you that we do actually get the same results. All right, I'll talk to you then. So now that, as you can see, the PyMINEr run has finished, we'll go over and take a look at the results. Just going to look at the HTML file this time around and see what our genes of interest look like. And as before, the heat map comes out exactly the same, as did the clustering results. And if we look at the marker gene plots, they look very, very similar, or in this case, exactly the same. So as we can see, the results essentially came out exactly the same. And lastly, we'll just look at some of the affinity matrices plots and everything else, and again, they look very, very similar. The UMAP is basically a little bit shifted, but yeah, there's a little bit of noise just from differences in random seeds, but basically all the major results come out the same, whether or not you use your input text files or if you convert whatever data representation you have into PyMINEr's HDF5 file format, which again is just any an HDF5 file that you can use with the H5Py package, with only the object in it that says infile as the keyword, and you can load anything else you want in there, but PyMINEr won't really look at it. As long as there's the infile and then leading to the matrix that contains all of the data. So yeah, you should be able to, and I have used this on something as large as the Tabula Muris on a regular desktop computer, no high performance computing required. And yeah, it opens the door to running all these automated analyses and running things quickly, without needing to do all of the programming yourself. And yeah, that's all. And thanks for listening. All right, until next time, take care.